two HC-05 Bluetooth modules, and the ultimate goal is to have these two Bluetooth modules connecting to each other. And to achieve that, we are going to be using the circuit. Some key features of the circuit is that we have a switch, and the first switch controls the mode. It helps you select the mode. Either you're programming the master or the slave HC-05 Bluetooth module, and the push button you are seeing is to initiate the configuration. So yeah, basically when you press it, a series of commands are transmitted to the selected HC-05 Bluetooth module, and the LED's functions are related to the operation of the first switch. When when it's on, it indicates that you have selected to program the slave. This LED will be on to select that we are configuring the slave HC-05 Bluetooth module. When the red is on, it indicates that we are configuring the master HC-05 Bluetooth module. And we have two more LEDs, and this LED function is important. It indicates that we are receiving the expected responses from the HC module that we have selected to configure it. And the red one, that's basically the opposite. When it's on, it serves as a warning to us that we did not get the expected response from the HC-05 Bluetooth module. And this section is where we're going to connect either one of these modules. That will depend on which one we choose to program. But essentially, the slave denoted with S here will be the first to be programmed, because we want to extract the address of this HC-05 Bluetooth module and assign it to the Bluetooth module, which is denoted with M for master. And this is important so that you don't get your modules mixed up on a later stage when they're stored and you don't know which one is the master, which one is the slave. And of course, you can reprogram it if you have a programmer like this, which I have designed. And also, it's connected to the software terminal. On terminal, we are going to view the contents that we receive from this Arduino. It uses the AVR. We're going to transmit some commands, and we're going to see those also on terminal. We've set the correct baud rate and ensure that we are connected. Now it's connected, meaning we're connected to this. And what we're gonna do, two switches which I did not mention anything about, is that we have the power here. So what I'm gonna do is I'm gonna take one HC module, which is the slave. I'm gonna connect it on the section that I've told you about, and it should automatically go into AT command mode, allowing us to send a series of commands to this module. So if I power this, I'm gonna switch on this. Both these switches are for power. The other is for VCC and the other is for ground. I'm gonna switch them on, but I want my focus to be on the device. So what I'm gonna do is I'm gonna switch them on, both of them on. You see that it was blinking fast, but now it's blinking slower to show that it's currently in AT command mode. And because the switch here is on, it shows that we are in slave mode, and this LED is on, not this one, but this one. And when I initiate the configuration, you should have this green LED switching on to show that we are getting the expected responses. Okay. At first, you can tell that we did not get the correct response. And if we go to terminal, you'll see that when configuring the slave device, the first command we got there wasn't expected, because if you look at this, you'll see that it's written by, which shows that the command wasn't what we're expecting, but the other commands are definitely okay. When we set the slave name, for example, and we also got the address, and also we wrote this address into the EEPROM, but the first one wasn't as expected. That's the reason you saw the green LED. So what we can do is we're gonna initiate this again, and then you notice that we did not get any red LED. So you see the importance of the red LED. I'm gonna go to terminal again. I'm just gonna scroll up to see the latest configuration. On our latest configuration, now you can see that we sent AT command and we got a response as okay. We set the role, AT plus role for 0. Then we got okay. We set the name, we got okay. We also set the baud rate. For data transmission, we got okay. We sent AT plus ADDR for address and we got okay. And then we were given the address. We then wrote to the EEPROM. We wrote the addrase basically to the EEPROM. So we have the address stored into our AVR. So now we are done with the slave. What I'm gonna do is I'm gonna turn off the power again by switching off these two LEDs. There's no power to the device. I'm gonna simply remove it from the circuit and put it down. Now we are taking the master. Back to the same section again, we just gonna have the master connected, and once it's connected, I'm gonna bring back the power again. But remember, since now we are in master mode, we can't have this one switching on. We want this one to switch on. So we have to change the state of this switch, obviously. So I'm gonna change it and drop it. And what you realize already is that this is already in AT mode, because obviously it was connected to that section for a while. Didn't change the camera focus to that. But when I press initiate, we are expecting this red LED to be on for master configuration, and we know that the address is already stored. So yes, this LED goes on, and we also had this one switching on. If there was a red LED which I didn't show, also on terminal, when we go there for master, let me scroll up now because we have done a new configuration. As you can see, master configuration, we send an AT command. What we got is that we got an okay. The role now, it's no longer AT role 0, it's AT role 1 for master. Then okay, then this AT plus C mode command, it's there to indicate that we are tying this master to a single slave, the slave that we are going to bind the address of. By that command AD bind, we give it the address. And then to set the name, we've done so. We also set the baud rate, and we got okay. So we got the expected responses. So yes, that is great, which means we are done programming both of these modules. This one is programmed and the other one is programmed, and I can even program it again. Obviously, if I then press this, you will see that it flashes and flashes and flashes and flashes, showing that we are getting the expected responses. At the end, it flashes quicker 6 times to show that we are done with configuration. Also on terminal, obviously there's an update. If I go up, go down, all the way down, you see now we've programmed the master, and also we did it again, because you can see that configuring master, and then the commands were sent again, also the address, and all the responses were okay. So how do we know that this is really working? Okay, what I can do for you is that I can remove one of the transmission lines, right? And obviously this LED now, when I try to configure, well, let me just remove both of the transmission lines, because I don't want to have to program the master again. We shouldn't get the green LED, because we won't be getting the responses, and also the transmission won't be successful. So when I press, we only get the red LED for all the commands, showing what? Showing that we did not get the responses, but the green LED flashes at the end to show that we are done configuring. But the red LED was warning us that we did not have a successful run. We're gonna check what happened on terminal. The last one, look on terminal. On terminal we said 80 roll, but we didn't get a response there. You can see that it's blank. For example, here when we said 80, we got okay, but here now we did not get anything because I removed the transmission line. And the buttons, the LED, I mean the red LED was proving to us that it's very helpful because you get a visual of the data transmission progress. Then you can see that okay, something went wrong, and our LED, the red one, shows that we are configuring the master. And I'm just gonna remove the master because we are done configuring this guy. Okay, so switch on the power as well. So yes, this is a programmer that I've designed. It's a very nice programmer because you can easily program either one of these modules after the other, but you basically have to start with the slave. But you don't have to go into using the Arduino IDE and try to type all the commands manually. This does it automatically. So my plan for this is to build this on a Vero board and solder it nicely. So in the future, when I want to program a HC-05 Bluetooth module, I just have to connect it on a section, and then I'll just have to press a switch, and automatically that module, that Bluetooth module, will be programmed.